Just sound like that.
No, it's sort of-
But if you'd skipped today, you couldn't have done any math outside
That's
of that.
why. It's 'cause I have such
Okay, so we're doing derivative tests first and second. So remember, when you take a derivative test, F prime tells you whether F is increasing or decreasing. F is increasing when it's positive and decreasing whenever it's negative. Okay, remember your critical numbers are when you take the derivative and you set it equal to 0. Then your maxes and mins happen whenever there's a sign change. So what direction would a max be? Plus to minus or minus to plus? It'd be plus to minus, yeah. And then a min would be minus to plus. So take a look at the first one. Okay, they give us F. That means that we want what? F. Oh, hey, bud. We want F prime. So what would the derivative be for 300x minus x cubed?
300.
Yep. Okay, then from there, take out GCF. So I'll take out a 3. And that gives me 300 would drop to 100 minus, that'd just be an x squared. Now, even though the order of subtraction is kind of odd on that with the 100 first and the x squared second, you can still do perfect squares on it. You just need to keep it true to the order it's already in. So for example, square root of 100 would be 10. Square root of x squared would be a plus x and a minus x. You also could take out a negative and then reverse the order of subtraction like we talked about in class today. Okay, then from there, what are our critical numbers? Okay, 10 and negative 10. Okay, the only reason that, yeah, the only reason 0 doesn't count is because that's just a 3, not a 3x. But if it had an x with it, 0 would be an extra. Okay, then from there, set up your number line. Okay, we'll put negative 10 and 10 on it, and then pick a number bigger than 10. What could we pick? Okay, 12. 10 minus 12 comes out negative. 10 plus 12 comes out positive. Multiply a negative and a positive, get a negative. Okay, then no double root, so I know it's going to switch plus minus. Okay, actual AP test though, you're welcome to check each subinterval.
What's a double root?
A double root is if, like, let's say you had a term that was squared, where like anything squared is always positive, so it can't change sign. Another example of a double root would be a 4th power, anything in absolute value bars. Those are pretty much the main two. Okay, so then we want increasing, then which number line piece do we want?
Positive.
Yeah, so negative 10 to positive 10. And then remember that if you're labeling your number line, these are the signs for F prime that they tell you what F is doing. So when F prime is negative, regular F is decreasing, versus when F was positive, that's when it would have been increasing. And sometimes that'll help you to see where the maxes and the mins and all that stuff are. So it'd be from negative 10 to 10. Where would my relative min be? Yep, and then your relative max would be at 10. Okay. All right, go to the next one. We have an f of x. This time it asks you for an absolute max. We're going to start off the same way. Okay, first thing we need is to take the derivative. What would f prime of x be? Yes, 3x squared plus 6x minus 9. Okay, then we're setting that equal to 0 to find our critical numbers. What'd you say? Yeah, pull out a 3. So then I'll have x squared plus 2x and then minus 3. Well, we'll multiply to 3 and add to 2. They have to multiply to 3 though.
So 3 minus 1.
Yes, plus 3 minus 1. Okay, then remember those numbers you're finding are called critical numbers. Or sometimes on the AP test, they'll call them critical points, but it's the same thing. So it'd be -3 and 1. Okay, set up your number line. -3, +1. Pick a number bigger than 1. Let's say we pick 2. 2 minus 1 is positive. 2 plus 3 is positive. 3 is also positive, which means that that far right interval is plus. No double roots, so I know it's going to flip-flop plus minus plus. That tells us that F goes from increasing to decreasing to increasing. Okay, that makes -3 a relative max. Okay, but they're not asking you for the relative max. What are they asking you for? Yeah, the absolute max. And here's the difference. Okay, if your graph goes like this, I'm gonna give you 2 pictures. Okay, let's say it goes like this and then it's cut off. Is my absolute max the same as my relative max?
Well, yeah.
Yes, because not only is it the highest in this hump, but it's the highest overall. What if your picture looks like this, where it goes up, down, up? Where's your absolute max now? It'd be on the end point. So the relative max doesn't necessarily have to be the winner. The way that you check is a candidate's test. So to check for this is a relative max, to find absolute max, you need to make a chart. You're gonna do candidates chart. Okay, and the 2 things that need to go in the candidates chart are the endpoints, which are -4 and 2. And then any critical numbers of the type that you want. So for example, if I'm looking for a max, I'm not going to put 1 in the chart because I know that's a min and there's no way it's the biggest overall. So I'll put -3 in it. Okay, then we are plugging in. Let's start with -4. What is -4? And also one quick thing here, you're plugging into the original f of x, not to the derivative. So for my -4, I'm going to have -4 cubed plus 3 times -4 squared, 9 times -4 minus 4. And a lot of times, even though it looks kind of annoying, a lot of times the numbers will kind of work out to not be too bad. So that's going to be -64. 4 squared is 16 times 3 is going to be 48. Okay, also make sure that you square first, then times by 3 second. We got to follow PEMDAS there. Okay, then -9 and -4 is going to give you a plus 36 and then a minus 4. Okay. Then from there, 36 minus 4 is going to give me 32. And then what's 32 plus the 48 in front of that? Close. 80, and then 80 minus 64 would be 16. Okay, then we're doing the same thing with 3. So I'd have 3 cubed plus 3 times 3 squared. Oops, this is a -3. And then minus 9 times -3 minus 4. Plus or minus 27. -27. What about the second one? So that's a plus 27. Those cross each other out basically. So then I just end up with 27 minus 4, which is 23. And then my last endpoint, we're plugging in 2. So that'd be 2 cubed. 3 times 2 squared minus 9 times 2 minus 4. So you said that's 8 plus, that'd be 4 times 3 is 12 minus 18 minus 4. 20 minus 18 is 2 minus 4 is -2, yes. Okay, and then looking at the chart, you would just say, okay, which of these is the biggest? So our absolute max is 23. And remember, the absolute max is 23, and it occurs at x equals -3. So if they say, where does the max occur? You'd say -3, but if it says, what is the max? You'd say 23. So that'd be answer choice D. Good on that? All right, let's do some second derivative tests. Second derivative test at the top tells you about concavity. The graph is concave up when the second derivative is positive, concave down when the second derivative is negative. Okay, and then your points of inflection are where F double prime changes sign. Okay, it's not a specific order though, like mins and maxes. As long as it switches, whether plus minus or minus to plus, it's still a concavity change. Okay, so let's do the second one. Let's skip this one. Let's go down to this one. Okay, so we want the graph to be concave up. Is that first or second derivative test? Concavity is second derivative test. So we'll take the derivative twice. So f prime of x equals what? Close. 5 times 3 is 15x to the 4 minus 3 times 20 is, yes. Then we're going to set it equal. Oh, wait, are we setting it equal to 0 yet? Oh, yes. Okay, are we taking the derivative once or twice? Twice. So then I don't need to set that one equal to 0. I need to go one more. So then 4 times 15 will give me a 60x cubed minus 120x. And then we're setting that equal to 0.
Plus C.
Ooh, that's for name time. Oh, I was like, oh no. Okay, so 60x, what's left over?
It's square root is 2x or 2.
2. Good. And now this can still be factored. Okay, the square root of 2 is not pretty, but you can still break that down. So you'd have a 60x, x plus root 2, and an x minus root 2. So this is still a difference of perfect squares. Okay, however, since you can't square root 2, you just kind of leave it like that. Okay, from there, how many critical numbers do we have?
3.
There are 3. Okay, the x in the front gives you 0. Then you have a minus root 2 and a plus root 2. Okay. 0 in the middle, root 2, negative root 2. Okay, and then if your number's a square root 2, I'd pick another square root as your example. So like, let's say my point, I want to try square root 3. What would square root 3 minus root 2 be, plus or minus? Plus, because root 3 would be bigger than root 2. Then root 3 plus root 2, that'd be positive. And 60 root 3, that'd be positive, then this is plus. Okay, versus a number smaller than root 2, maybe I'd pick root 1. Well, root 1 minus root 2 would come out negative. Root 1 plus root 2 positive, 60 root 2 positive, so that would be negative. Okay, but if you remember your double root rule, then you can just kind of flip-flop the signs, so plus minus. Then we want concave up. So we want the positives, F double prime. Positive means that F is concave up on these two, down on these two. So then which answer would we want here? Be negative root 2 till 0, and then root 2 till infinity, which is the same as B. Yep. Good. Okay, take a look at the next one. It says, let F be the function defined by, you have an equation. And then it says, on which intervals is F, I think that was supposed to be prime of X. Or wait, never mind, that is just, yeah, F prime of X. Positive and decreasing. Okay, this is a little bit confusing, but let's break it down. If I want F prime to be positive, what kind of derivative test am I going to have to do? Okay, is So it'd be a first derivative test and it needs to come out positive. But then I want f prime to be positive and decreasing. So if f prime is decreasing, what is that telling me the sign of? Okay, so it says we want f prime to be positive, so we know the first derivative test needs to be positive. But if
So the
f
second
prime
derivative.
is decreasing, the
So
second
derivative.
derivative has to be negative. Does that make sense? Because if f prime is going down, then that means its slope or its derivative is negative, meaning f double prime. So this is going to be a second derivative test needing to be negative. Okay, so let's start with the first derivative test. Okay, if this is f, what would f prime be?
X squared.
3x squared minus 6x. Setting that equal to 0. Take out a 3x, what's left over?
X,
X minus 2. Critical numbers are 0 and 2. Okay, I'm going to set up my number lines right over here, because remember, anytime you have a double line chart, you want to kind of stack them. So I'm going to do my f prime one right here. Okay, 0 and 2. Bigger than 2, say I pick 3. 3 minus 2 positive, 3 times 3 positive, so it'll be plus minus plus. And then I want this far left and this far right.
let's just go.
Oh, poor honey. All right, second derivative. Yep. 6x minus 6 equal to 0. Take the 6 out, x minus 1, which means that your critical number is going to be 1 for that line test. And then this is where I would try to stack them. So like if this is 0 to 2, then I want to make sure that my 1 ends up in the middle. And then if I want that to be bigger than 1, I could pick 2. 2 minus 1 comes out positive, times it by 6, it's going to be a plus and a minus. But then for the second derivative test, what was the sign that we wanted? Negative. So then where's the overlap? Negative infinity to 0. Good job. So you'd only want where both of those conditions are met. So it'd be answer A. Make sense? All right.
First time it's not makes more sense.
Yes, good.
And then we did like 3 more months of having to do this, the other stuff.
And then you forgot everything.
Yeah, and I had struggled for a while.
Okay, look at the
It's like
bottom
this-
one. I know, some of it, it's a lot in first semester, but hopefully it'll start coming back.
Yeah.
What rule, okay, first question, what derivative test, first or second for that second last question? We
Oh,
want,
that one first.
that's a first derivative test, because increasing, decreasing is an F prime question. Okay, but then if this is my F, what rule are we gonna need?
Oh, product.
It is product rule, good, because it's a function times a
remembered stuff.
function. Yes, let's go. Okay, so your U is gonna be x squared, and your V is gonna be 2x. Okay, but this is gonna need product rule. So if my U is an x squared, my V is an e to the x, remember, I take the derivative of both of those parts. So what is U prime? 2x. What's the derivative of e to the x? E to the x. And then remember, for product rule, you do one diagonal plus the other. So f prime of x would be, I'll do this one first. So it'd be x squared e to the x plus, for product rule, 2x e to the x. Okay, and then from there, we're setting that equal to 0. Do we have a GCF? Yes, we can take out They both have an e to the x, right? What do they also both have? An x. So I'm gonna take the e to the x out first, then the x, and then what's left over?
X plus 2.
Okay, let's find our critical numbers. Okay, if I have an x on the outside, what's that number? 0, -2. Now, what about e to the x? Does e to the x ever equal 0? Think about the graph. No, e to the x looks like this. Okay, remember, it has an asymptote on this side, but it never actually gets to 0. So the e to the x part of this is always positive. It'll never hit 0 and give you an extra critical number. So we only have 0, -2. Put them on your number line. Bigger than 0, let's say I pick 1. 1 plus 2 is positive, times 1 is positive, e to the 1 is positive, all the way positive. Okay, then we know it'll flip-flop negative plus. So if we want f decreasing, which window are we looking for? Yes.
The-
It'd be big. Very good. Okay, take a look at the next one. We might come back to that FRQ, we'll see. We have time. Okay, so look at the next one. We have f prime of x equals x squared minus 4 times g of x. Okay, then it says, which of the following is true? So we have lots of stuff about relative maxes, relative mins. What type of derivative tests are we doing?
Second, first.
First, and do we need to take the derivative?
No.
No, because what did they already give us? The derivative. So then I just take that and set it equal to 0. Very good. So I'll have 0 equals x squared minus 4 times g of x. Can any part of that break down?
X, 2x, 4x.
What?
You take out 4x.
Can you? This
Oh, not
is
from-
totally separate.
Yeah, so you could take out 4x from the first one.
Well, this one doesn't have an x though. You can do something.
Oh, you could take out the 1.
Simplify it by, you're saying so many things and yet,
X plus 2 times
yes. Perfect squares. So you'll square root both of them. It'll break down into +2 and -2. And then g of x. Okay, then what are my critical numbers?
I don't want to talk about
There, 2 and -2. Okay, now let's talk about g for a second, because g, we don't even know what it is. What is the one thing that they tell us about g in the problems?
it. Less than 0.
So is it ever equal to 0 to give me a critical number?
No.
No, that also tells me that the sign is always plus or minus. It's always a negative. So when I do my sign chart, we need to remember that this is always going to give a negative result, no matter what we plug into it. So we'll put -2 and 2. Bigger than 2, say we pick 3. 3 plus 2 is positive. 3 minus 2 is positive, but what is g of x?
Always negative.
Negative. So a plus, plus, minus, overall that interval is negative or minus. Okay, then between them, we know it's gonna flip flop. And then that means that if g f prime, sorry, goes negative plus minus, then what will regular f be doing? It'll go decrease, increase, yeah, decrease. So then what's my extrema at -2? Min or max? That's a min versus +2 is a max. So we would want B, relative min at -2, max at 2. Okay, take a look at the next one. Okay, we have a graph of f. This is f of x, and they're asking me to compare all this crap. So if you look at them, they're all in different orders, but it's all the same 3 things. They're asking me for f of 1, f prime of 1, and f double prime of 1. So let's write each one of those down. Okay, f of 1 is what feature on the graph of f? What would, huh? It'd be the point. So at 1, what's the y value? 0. So f of 1 is 0 because that's the y value for that point. Okay, what feature is f prime of 1 on the graph of f?
Slope.
The slope. Now, I can't calculate the exact slope, but is it uphill or downhill?
Awesome.
We know it's positive because the slope is uphill. Okay, the second derivative is what feature? The concavity, very good. And what's my concavity? Up like a cup or down like a frown? Okay, so it's negative because it's concave down. So then if I wanted to order a positive, a negative, and a 0, which one would be the smallest? Yeah, so we can get rid of A, B, C. And then after f double prime, what should the next smallest be?
D.
Regular f, so it'd be D, and then f prime last. Make sense?
Yeah.
All right, next one. It says we want a positive first derivative and a negative second derivative. What does a positive first derivative mean for the graph?
That means it has to be increasing concave down.
Very good. Increasing. And then the negative second derivative means concave down. So let's start just with the increasing. Which chart does not have increasing y values? Okay,
Oh, why values?
yeah, the y's have to be getting bigger each
C,
time.
D, E.
Yeah, so we can actually go down all the way to only 2 answer choices. Okay, out of the 2 that are left, draw a little graph that's increasing and concave down, just like a little piece. So if it's increasing and concave down, it needs to look kind of like that, right? Okay, is it getting steeper or flatter as your x's go out? It's getting flatter. Then basically your jumps between the y values
Small.
need to be getting smaller.
A.
I think it's actually B, because 7 to 11 is +4, but then what's the next jump? Only 3.
I just saw bigger numbers. And I thought that.
Yeah, so basically if your jumps are getting bigger, your graph's getting steeper. If your jumps are getting smaller, then your graph will be getting flatter. Also, one more quick thing, if the first and second derivative are the same sign, your jumps will be getting bigger. If they're opposite signs, your jumps will get smaller. Huh? I said that if you're, I can draw it right here. Draw this, and then this, and this. Okay, for the very first graph, is it getting steeper or flatter? This one right here. Okay, the reason it's getting flatter is that your f prime is positive, but what's your f double prime? It's bent down like a frown. Okay, the other version of that would be this one right here is all, which other one's getting flatter? This one right here. And what is f prime on that graph? Decreasing, but what's f double prime? Increasing because it's concave up. So basically, anytime that the signs are opposite, that's where your graph's going to be flattening out. And you can kind of think about in all the particle motion stuff when we would say like speeding up or slowing down, it's the same concept here, that if your first and second derivative are the same sign, your graph will be getting steeper like on these 2. Okay, on the first graph, what are both of the signs up here? Yeah, f prime and f double prime are both negative, versus on this one, they're both positive. And that's what makes it get steeper versus flatter. Okay. All right, we have a little bit of particle motion here. Let's take a look at the next one. Okay, it says, when is the particle at rest? Okay, so at rest, means you want your velocity to be 0. Okay, so then remember, you're just gonna take whatever the velocity is and basically set it equal to 0, because that means you're not moving. Okay, what does x of t stand for? And remember, it goes PVA. So if I want to go from position to velocity, that's a derivative. Very good. So what would your derivative be for that? Yep. And then make sure if it's multiple choice, it doesn't matter, but for FRQ, you want to label that. So we would call that V of t for velocity. Okay, what can we take out of all three of those? Okay, a 6. Yeah, just a 6. Okay, and then equal to 0. So we'd have minus 7t in the middle, and then 72 divided by 6 is, well, we'll multiply to 12 and add to 7.
6 and 2.
That adds to 8, close.
6 and 1. 12 minus 5.
What numbers times to 12?
4,
4 times 3. And then to get him to add to minus 7, we'll turn them both negative. You were on the right track. You were saying numbers.
I was saying numbers. Wow.
You were saying numbers. I respect your bravery. And then it'd be 3 and 4. Now, one more thing here. If it had said, where's their relative max or relative min, that's where you do a sign chart. But if all you want is for it to be at rest, setting equal to 0 is enough. So it'd be E. All good on that?
Yeah.
Okay. Next one is kind of an interesting question. Again, you have position. You want to find what is the acceleration of the particle when the velocity is first 0. So we have, so what do we need to do? Okay,
So you already have. So yeah.
so we have position. So how will we get to acceleration? We'll take the derivative twice. So let's start with that. So if x of t is sine t minus cosine t, then what would velocity be? Remember your snow cone, snow cone.
Plus sign.
So sine would go to positive cosine and negative cosine would go to plus sine. Are we all good to there? Okay, then let's take one more derivative for acceleration. What's the derivative of cosine?
Negative sign t.
Negative sine t. And then sine would go to a plus cosine t. Good so far? Okay, then it says, what is the acceleration of the particle at the point when the velocity is first 0? So we need to find this when the velocity is 0 to know what to plug in for acceleration. Does that make sense?
Yeah.
So I'm going to take this velocity, and if I want it to equal 0, I'm going to set it equal to 0. Okay, let's bring one of the equations across to the other side. So I'll just do cosine. So if my cosine crosses over, now it's negative cosine t equals sine t. Okay, now think about, on the unit circle, what angle are sine and cosine equal to each other?
No.
Okay, on your hand, where are your fingers the same? Top and bottom.
That's
So you want 2 fingers on top,
or middle.
2 fingers on bottom, so it has to be pi fourths. Very good. Now, there's one problem though. If I go to pi fourths, they're both positive. And I want one of them to be negative and the other one to be positive. So then I'm not going to pick pi fourths here. I need to pick whatever this angle is here. So let's review how to find that. Halfway across the circle would be 1 full pi, 4 pi fourths. It'd be 3 pi fourths. Very good. So if it's 4 all the way around to the top half, then I'd have to back up 1 and pick 3/4 for my time. Okay, when they're essentially the same value but opposite signs. So that's my time. And then it says, what is the acceleration when the velocity is 0? Well, we know the velocity 0 at 3/4. Then we can plug that in right here. So acceleration at 3/4 equals, let's see, negative sine 3/4 plus cosine 3/4. Okay, now remember, 5/4 is your middle finger. So sine and cosine are both going to be what fraction? It's root 2/2. So then this is negative root 2/2 plus root 2/2. Okay, now there's one other problem with this that we have to think about. Do you remember the all students take calculus or all Star Trade class? Okay, so remember that that tells you which functions are positive in which quadrants. So for the A, all 3 of them are positive. For S, only sine is positive. Cosine and tan are both negative. T, tan is positive, but the other 2 are negative. And then in the C quadrant, only cosine is positive. So if I'm not plugging in 5/4, but I'm plugging in 3/5, then my sine value is exactly what I wrote down, root 2/2. But what is my cosine value going to be? Negative root 2/2. And then if I do negative root 2/2 plus another negative root 2/2, think about it's like you have one root 2 cut in half plus another root 2 cut in half, and you're going to have one full root 2. Because these are both halves, and you're essentially like adding them together. Okay. Other thing I would say, if you're not good at trig, you skip that part of the AP test. Like those questions, come back to them. But this had tons of trig in it, and it's worth the same in multiple choice as all the other questions. You know what I mean?
So don't do trig.
I'm not saying don't do it, but I'm saying choose wisely, you know. Okay, so I want to go back to that FRQ that we skipped. And this, we probably won't get through all of it, but we'll get through what we can. Okay, so it says, consider this function. And then it says, find all intervals where f is increasing and decreasing. Okay, now on the AP test, usually they'll just ask you for one, but I made this question, so that's why both is on there. Okay, so if this is my f of x, how can I take the derivative of that? Okay.
Oh.
Okay, do you remember how to bring that x up?
Negative.
There we go. So if it starts out with a fraction, you're gonna have to do a rewrite. Okay, so it'd be x plus 16x to the minus 1. Does that make sense? So we haven't taken the derivative yet, but you have to pull the x up first to do power rule. Okay, then what would your derivative be?
1 plus.
Negative 1 times 16 would be,
1 minus 8x.
and it'd be a 16, right? Because you're doing negative 1 times 16, and then you take away one more. You multiply the original exponent down though. Did you make it a 1/2?
No.
How are you getting that to be an 8?
Because it's minus 1, so it becomes an x to the negative 2.
Oh, okay, remember, for derivatives, you times the original down and then take away 1.
Wait, wouldn't it be minus 16 x minus?
Yes, sorry, so then the minus 2.
Why do you want it to be?
Because I'm crazy. So we times the negative 1 down into minus 16, decrease the power to a negative 2, but now we have to do a sign chart on that. So we need to get it back into fraction form. So we have 1 minus, and then my x to the negative 2 now needs to go back down to the bottom. Okay, and you cannot sign chart it like that. We need to get a common denominator so that it's like one big fraction instead of one minus a fraction. So what could we times the x squared by to get a common denominator? Or times the 1 by, sorry. We do x squared over x squared. So now here's what you have. X squared minus 16 on top over x squared on bottom. And now that that's one big fraction, it's factorable. How could we break down the top?
X plus 8, x minus, oh wait, no, x plus 4, x plus.
There we go. And then the other thing that is easy to forget on these is that critical numbers can be anywhere. They can come from the top or the bottom. So from the top, what are my two critical numbers?
4 and
But then from the bottom, I'm gonna get 0, because there's an x kind of like by itself on the bottom. And if you miss that critical number, then you'll miss some of your mins and maxes. So then 0 is here, -4 and 4. Bigger than 4, let's say we pick 5. 5 minus 4 is what? Positive or negative? Positive. 5 plus 4 also positive. 5 squared also positive. Okay, then my next number is 0. What term gave me the 0 in this equation? The squared is a double root. That means that it's going to change sign when it crosses the 4, but it's going to stay the same when it crosses the 0. Because x squared was a double root, that means that 0 can't change sign. And then it'll change here to be a +4. So then it says, where are my extrema? Well, at -4, what type will it be? It'll be a max because it goes from plus to minus. What about at 4? It'll be a min. So you'd say you have a relative max at x equals -4. Because since it says justify, f prime changes plus to minus. And you can use the plus and minus symbols to represent positive to negative. And then same thing for the other, relative min at x equals 4, because f prime changes -2 plus. Okay. The next part of the question asks for a second derivative test. Okay, and we're not going to actually do it, but what would be the easiest place to take the second derivative from? Would we want to do it from here and use quotient rule, or take it from here and do power rule? Power rule. So all I want you to write for part C is you want to use f prime of x before you made it ugly. So keep it like that and then take the second derivative. Because if you try to use it in the fraction form, then it's going to end up like looking all crazy where you'll have a quotient rule within a product rule and you don't want that. So your derivative would come out to be what?
positive.
X to the -3, which means 32 over x to the 3, which means what's my only critical number?
32 and 0.
Well, 32 doesn't
0.
have an x, so it'd just be 0. And then on your number line, if 0 is your only critical number, any number bigger than 0, how's that sign going to come out? Positive versus any number less than 0, when you cube it will stay negative. So then everything to the left will be concave down, everything to the right concave up. Make sense? Good job. Very good. Okay, and then if you have your sheets, I'll sign them. Do you need one, Kat, or you already have one? And then also I forgot to have this sign it out. Sign it on this is a sheet. Here's the bottom right there. And then you took sign there because you took the mock exam. Yeah. That's fine. And then do this one. And then Luke, I think you just need to initial for today on that same sheet.
then what about the minutes?
Did you go to those? Then yes, initial. Are you really gonna do every single one?
Yeah,
Let's go. Wait for it. That was the very first one on Monday. It's first, and I, this is what I put, first slash second Durham test. Yep. Did you get a lot of that homework done? Or do you still have a lot left?
I have some left. I can finish it now, so.
And did you sign it or you still have to? And if you want to work on it during advisory tomorrow,
Okay.
then I can do it.
Some of my homeworks are like older grades. Can you like?
Uh-huh, I'll do it now before I leave.
There's a couple of.